Hello everyone, my name is Dhairya and in this video I will explain a simple C# program using a class called animal. As you can see, there are many properties in this class like name, diet, location, weight, age and color of an animal. So it also has methods like eat, sleep, make noise, make lion noise, make eagle noise and etc etc. These methods define what an animal can do. So let's come to the main method. We created three objects: William the wolf, Tony tiger, Edgar the eagle. Each object is created using the animal class and has its own values like name and weight, as you can see here. After creating these objects, we call different methods. Wolf make wolf sound, eats meat and sleeps. uh, Here is this uh, tiger makes lion sound and eats meat. Eagle makes eagle sound and eats. Each object behaves differently based on the method we call. This program shows how class can be used to create multiple objects. Each object represents a real world animal and performs actions using methods. So this was the basic example of classes and objects in C#. In the second question, first we have a base class called animal, which has these properties like name, diet, location, weight, age and color, which were same as above. So it also has basic methods like eat, sleep, make noise. These methods define general behavior of the animal. Now the tiger class. Next we created that. In this we created a tiger class which which inherits from the animal class. We use the syntax tiger colon animal to show inheritance. The tiger class also has its own properties like species and colored stripes. It uses the base constructor to initialize common properties. In tiger class, we redefine some methods like make noise, prints roar, eat, prints tiger eats meat. This program shows the inheritance where a child class reuses and modifies the behavior of a parent class. Animal class here is parent class and the tiger class is the child class. So this was inheritance in question 2. Concept of polymorphism. Here is the same animal class from the above two questions and with same properties like name, diet, location, weight, age and color. Now in this we set up the virtual uh, keywords are marked as virtual, which means they can be changed in child cases. Next we have three child cases: the tiger, the wolf and the eagle. Here is the eagle. These child cases inherit from animal and override its method. Tiger overrides make noise, eat and move. The wolf overrides make noise, eat and move. Eagle overrides make noise, eat and move, and it also has an extra ability to fly. Now in the main method we created objects of tiger, wolf and eagle with the same method. When we call the same methods like make noise, eat and move, each object behave differently. For example, the tiger roars, wolf howls and eagle whistles. Even though the method names are same, but the behavior is different. Polymorphism means one method can have many forms. Here, same method like eat works differently for each animal. So this program shows method overriding and runtime polymorphism. Code explains the hierarchical inheritance and polymorphism. So first we have the base class called animal, which is same from the above three questions, and its methods are also same. Now we created two intermediate classes, feline for animals like tiger and lion, and bird for animals like eagle and penguin. Then we created specific animal classes. Tiger overrides make noise and eats. Lion has its own. Lion has its own methods for sound and movement. Wolf overrides make noise and eat. Eagle overrides fly. Penguin also overrides fly but shows different behavior. This shows how different animals have their own specific actions. In the main method, we create objects of all animals. We call the same methods make noise, eat, sleep, etc. Each animal behaves differently. For example, the tiger roars, wolf howls, penguin cannot fly but swims. This is polymorphism where no method has different behaviors. This program shows hierarchical inheritance where multiple classes inherit from a base class, and polymorphism using overriding. The fifth question explains method overriding and method hiding in C#. First we have class A. It has two methods, M1 and M2, which is M1 which is marked as virtual and M2 which is normal method. Next, in class B inherits from class A. It overrides method M1 using the override keyword, as you can see, and it also defines its own M2 method, but this is not overriding it. It just creates a new method. Then we have class C, which inherits from class B and which has the M1 which is written again but without override keyword. This means it is hiding the parent method, not overriding it. In the main method, we create objects of A, B and C. In part A, we add A.M1 calls A's method and B.M1 calls B's overridden method. In part B, we write A.M2 calls A's method and B.M2 calls B's method. C.M1 calls C's method because it hides the parent method, and C.M2 calls B's version since C does not override it. This shows the difference. Override changes the parent method behavior, and hiding creates a new method without replacing the parent one. The question 6, which is the last question, which explains method overloading. In this program, we have a class called overloading. Inside this class, we define two methods with the same name. Method to be overloaded, bracket string name, and method to be overloaded string name comma int age. Both methods have same name but different parameters. This is called method overloading. In the main method, we call both versions of the method. First, we pass only the name. It prints the name. And in second, we pass both name and age simultaneously, and it prints both. The compiler decides which method to call based on the parameters. Method overloading is an example of compile time polymorphism. it allows us it allows us to use same method name for different tasks. So this was all about uh, polymorphism, method overloading, overriding, hiding,